welcome to an algebra tutorial video working our way on linear equations. This particular video, I want to define a linear equation relationship, but then look at how we can see the linear relationship in a table of values. So I've got a context to help give us some understanding as we put this equation together. We have a taxi service, charges a $5 flat fee for a taxi ride, plus 20 cents per mile traveled. Show this relationship in a linear equation and a table of values. So let's start by a linear equation. We know linear equations always fit the form y equals mx, that's m times x plus b, where b is our starting value. It's a constant term, it's just a number. M is my constant rate. It's describing the change that is happening, what is repeatedly being added over and over again. And x and y are my variables. I'm looking to see how does x relate to y, how does x affect what y becomes. So I'm looking to put together an equation in this form. In particular, with this example, let's define our variables as x is going to equal the number of miles traveled, because that's what's changing independently, right? I'm traveling a number of miles. And that's going to affect the overall cost of the taxi ride. So it's always important to think about your variables. What meaning do they have? How are we relating them together? In this case, x is number of miles, y is the cost of the taxi ride. And if I put together my equation, well, the cost of the taxi ride is equal to $5. So I'm going to put that in for B. It always is $5. It's my constant starting amount. Plus, I'm adding to that 20 cents. So 0.20. It's 20 cents for every mile traveled. And that's what X is, the number of miles traveled. So that 20 cents has to multiply X. And there you go. You can see, starting with 5, and there's my multiplier of 20 cents per mile traveled is going to all together, those two things add up to the total cost. So I've got an equation together. Hopefully that makes sense how we put that equation together based off what we have here in the problem. But now let's see this changing pattern happen in my equation here. So I'm going to let my x values be on the top here, and I'll let my y values be on the bottom. And let's look and see if what pattern happens in our table, how that relates to our equation. So let's go 0 miles, 1 mile, 2 miles, 3 miles, 4, 5, 6, and 7. We'll go up to 7. So now how does my cost relate to these growing number of miles? Well, if I grow 0 miles, that would be putting 0 in for x into my equation. 20 cents times 0 is going to be 0, but I still have a $5 flat fee. So that would be like the taxi came, picked me up, even though I haven't gone anywhere yet, just for him being there is $5. So there we go, $5. Now I know every mile I travel is an additional 20 cents. So if I go 1 mile, it's going to be $5. And 20 cents. If I go 2 miles, that's 0.20 times 2. So that's going to be $5.40. If I go 3 miles, that's $5 plus 0.20 times 3. It's $5.60. $5.80. Hopefully you get the idea. If I go 5 miles, now I've broken in, it's going to cost me $6, $6.20. and $6.40, and it goes on and on and on, right? Depending on how many miles I travel. Well, a couple of things I really want to point out based on what we have here in our equation compared to our table. This value of 5, my value for B, should always show up when we have an x value of 0. It's my starting value, right? Before I've done anything, before I'm changing, before I'm doing anything with my x values, I start at a value of 5. So we can see that in our table, we can see that in our equation. They should be related in that way. Now, once I start there, notice in my y values, we're changing by the same amount over and over again, right? I'm adding 20 cents, adding another 20 cents because I went another mile, adding another 20 cents for another mile. This pattern shows up in our equation right here. If I have this value in for m, I should see that in my table as what I'm repeatedly adding over and over and over again along my y values. So hopefully this makes a little bit better sense when we're working with linear equations in this form, how in our table we can see our starting value, or our value for b, and we can see our value for m show up as we make a table of values.